Hello teachers, hello students. I am Dr. Tokkumma getahun, and today we are going to discuss about electrolysis. What is electrolysis? This is a process, okay, in which electrical energy is used to bring about chemical energy. Okay, let me begin from the definition of electrochemistry. I hope you are familiar about this term, electrochemistry. Electrochemistry is a field of chemistry that deals with the relationship between electrical energy and chemical energy. The devices that convert chemical energy to electrical energy or electrical energy to chemical energy are called electrochemical cells. And this can be classified as electrolytic cells. Electrolytic cells are devices that convert electrical energy to chemical energy. Another one is galvanic cell or voltaic cell. This also a device that converts chemical energy to electrical energy. Therefore, electrochemical cells can be classified as electrolytic cells and galvanic cells, or this galvanic cell can also be known as voltaic cells. And I told you that galvanic cells or voltaic cells convert chemical energy to electrical energy, while electrolytic cells convert electrical energy to chemical energy, or electricity or electrical energy is used to bring about chemical energy in electrolytic cells. Okay, examples of galvanic cells. The cells we use in flashlight batteries, wristwatch, cameras, and the car batteries are examples of galvanic cells. Okay, so what is electrolysis? Electrolysis is nothing but it is a process in which electrical energy is used to bring about chemical energy. If electrical energy is converted to chemical energy, this process is known as electrolysis, and it is carried out in an electrolytic cell. Because I told you that electrolytic cell is a device that converts electrical energy to chemical energy, and this process is carried out in an electrochemical cell known as electrolytic cell. Another name of electrolytic cell is electrolysis cell. What is electrode? Electrodes are strips of metal or graphite that allow electrons to leave or enter the electrolytes. Therefore, electrodes can be made from metals or from non-metals, graphite. Okay, we can classify electrodes into two. These are, the first one is anode and the second one is cathode. Anode and the cathode. Okay, anode is a positive electrode in electrolytic cell. Cathode is negative. But in galvanic cell, anode is negative and the cathode is positive in galvanic cell. So this is the difference between the two. I will also tell you the difference between electrolytic cells and the galvanic cells later. And anode is also an electrode where oxidation occurs, and the cathode is an electrode where reduction occurs. Another one, you are familiar about ions. Ions are charged particles. Ions can also be classified as cations, and the second one is anions. Cations are positively charged ions and anions are negatively charged ions. Therefore, in electrolytic cell, I told you that anode is positive but cathode is negative. So anions are negatively charged particle. I told you about this one. Therefore, they migrate toward anode. Okay, they are attracted toward anode and discharged by losing electrons. Cations migrate toward cathode and discharged by gaining electrons, and the reduction reaction takes place. Anions migrate toward anode and discharged by losing electron because they are rich in electrons. Then oxidation reaction takes place in electrolytic cell. Electrodes can be chemically active or inert. Active electrodes are nothing but electrodes that directly take part in chemical reaction. For example, zinc, copper, magnesium, these are examples of active electrodes. But inert electrodes do not directly take part in chemical reactions. They only serve to transfer electrons. Examples of these type of electrodes are platinum and graphite. So we can also classify electrodes as anodes and the cathodes. I already told you about this one. Anode is positive in electrolytic cell, only in electrolytic cell. But in galvanic cell, anode is negative. Cathode is negative in electrolytic cell, but it is positive in galvanic cell. So this electrode, anode, is connected to the positive terminal of the source, that is the battery, through which electrons leave the cell. Cathode, this is connected to the negative terminal of the source, through which electrons enter the cell. And during electrolysis, because we are talking about electrolysis, the ions of the electrolyte migrate to the opposite charge. I told you about this one. For example, anions migrate toward anode and discharged by losing electrons, and the cations migrate toward cathode and discharged by gaining electrons. So the ions of the electrolyte migrate to the electrodes of the opposite charge. Cathode, I told you that this is an electrode where reduction takes place, and this one has excess electrons, therefore cations will discharge by gaining electrons. So I told you about this one. Anode is an electrode where oxidation occurs or oxidation takes place, attracts anions. Anions are discharged by what? Losing electrons, because they are rich in electrons. At the anode, oxidation reaction takes place. Another main point is the reactions that takes place at each electrode is known as half-cell reaction. Oxidation half reactions occur at the anode and the reduction half reaction at the cathode. These type of chemical reactions are known as half-cell reactions. The rare reactions that takes place in the electrolytic cell is known as cell reaction. When you add these two half reactions, so you will get overall reaction. That overall reaction is known as net reaction or cell reaction. Cell reaction is nothing but the reaction that takes place in the electrolytic cell. The overall reaction is known as cell reaction or net reaction. This overall reaction is also referred to as an oxidation reduction reaction or redox reaction. Okay, redox is nothing but it is an oxidation reduction reaction. It comes from this one. We have, for example, RED from this reduction, OX from oxidation, REDOX. It is simply known as redox. Remember that oxidation and the reduction reactions takes place simultaneously in this type of chemical reaction. If oxidation is there but reduction is not there, that chemical reaction is not redox reaction. It is not oxidation reduction reaction. So electrolysis is the decomposition of what? An electrolyte using what? Electricity. So this is an external source. Okay, another main point is about electrolysis of molten or fused electrolytes. When ionic solids melt, they dissociate into positive and negative ions that are free to move. To understand the chemical reactions that occur during electrolysis, let us consider the hypothetical electrolyte MX. When, for example, this MX melts, so M plus and X minus will form. Therefore, this is cation. But this one is anion. This is anion. But this one is cation. Therefore, this one migrate toward what? Cations migrate toward cathode. And the reduction reaction takes place. X minus is anion. Anion migrate toward anode because this is negatively charged particle. But anode is positive electrode in electrolytic cell. Let us write oxidation half reaction. Anode half reaction, simply anode reaction, is X minus, okay? Then by losing electron to the anode, X plus 1 electron. Electron is lost. So this is oxidation half reaction. Oxidation, okay? You can say oxidation half reaction. Oxidation half reaction. In cathode reaction, for this hypothetical electrolyte, M plus will form after melting this MX. Therefore, M plus by gaining electron, 1 electron, because we have 1 positive charge here. After adding 1 electron, M will form. M metal will form in cathode. So this is reduction half reaction. What is reduction? You are familiar about this term. Reduction is nothing but it is a process in which addition of hydrogen, removal of oxygen, gaining of electron or reduce in oxidation number takes place. But oxidation is the opposite of reduction. Oxidation is also a process in which addition of oxygen, removal of hydrogen, losing of electron and increase in oxidation number takes place. Therefore, for example, you can see from this one, the oxidation number for this M plus is positive 1 because we have one positive charge on this M. Its oxidation number is positive 1. So the oxidation number for this free metal is 0. Why? Because for free metal, number of electron is always equal to the number of proton. Because of this reason, the oxidation number for this free neutral atom is equal to 0. So from plus 1, it reduces to 0. It decreases to 0. Therefore, this is simply known as reduction. But in the case of oxidation, this is negative 1. But here we have 0 on X because this is free neutral atom. Therefore, the oxidation number increases from negative 1 to 0. To balance this charge, electron must be added on the right hand side of the arrow. Because to balance, for example, if you add electron to the left, the negative increases. Negative 1 minus electron, that is equal to negative 2. Negative 2 is not equal to 0. To make equal, this electron must be added on the right hand side of the arrow. So we can write anode half reaction for this hypothetical electrolyte in this way. Cathode half reaction can also be written in this way. So this is after melting, M plus and X minus cation and anion, positive charge and a negative charge will form. So during electrolysis, M plus ions move towards the cathode. Why? Cathode is a negative electrode. I told you this one. M plus, this is positively charged ion. Therefore, it is attracted to the cathode. Then it gains one electron each and become M atom. I told you about this one. M plus, after gaining one electron, M will form. X minus ions move towards the anode. Why? Anode is positive electrode. But this is anion. Anion is negatively charged ion. Therefore, it migrates toward the anode. And by losing one electron, it becomes X atom. I told you about this one. X minus, okay, it can be converted to X by losing an electron. So we can write this half reaction in this way. So this is oxidation half reaction. It is a reaction that occurs on anode, because I told you that anode is an electrode where oxidation occurs. Oxidation takes place. Therefore, X minus, so X plus one electron. One electron must be added here to balance the charge, because here we have negative 1. Electron has negative charge. You are familiar about this one. So we have negative 1 on the right hand side of the arrow and the negative charge on the left. Therefore, the charges are now balanced by adding this one electron. And this reaction is oxidation half reaction. Why? Because the oxidation number increases from this X minus to this X neutral atom. Because of this reason, it can be named as oxidation half reaction. Another one is reduction half reaction. It is also named as cathode reaction. M plus, after gaining one electron, M will form. So this is reduction half reaction. It occurs on cathode, negatively charged electrode in electrolytic cell. Now, let us add the two half reactions to get what? Overall reaction or net reaction. Or you can also call them a cell reaction. So this is your cell reaction, or it is overall reaction. And this is simply known as electrolysis process. Therefore, this reaction is redox reaction, because we have oxidation half reaction and also reduction half reaction in this chemical reaction. This can be cancelled by this electron. Now add them together. We have M plus on the left hand side of the arrow. So M plus X minus on the left side of the arrow also. So plus X minus by electrolysis, M on the right hand side of the arrow. Okay. Plus what? X on the right hand side of the arrow. So all the time, electron flow from anode to the cathode. Anode is an electrode through which electrons leave the cell. I told you about this one. And through cathode, the electrons enter the cell. Therefore, the flow of electrons is from anode to the cathode. But current flow is in the opposite direction, from the cathode to the anode. This is your source. It is a battery, external source. Therefore, the positive terminal of this battery is to this side. It is connected to the anode. And the negative terminal of the source is this one. It is connected to the cathode. I already told you about this one. So this is an electrolytic cell, and this is electrolysis of fused electrolyte MX, hypothetical electrolyte MX. If you remember this one, all the time you can easily write the electrolysis of molten electrolytes. The number of electrons gained by cations must be equal to the number of electrons lost by anions. Then at the end you will get the final chemical reaction. That chemical reaction is known as redox reaction or oxidation reduction reaction. So all the time remember that the number of electrons gained by cations must be equal to the number of electrons lost by anions. A number of reactive metals like lithium, sodium, magnesium and the calcium, aluminum also, okay, these are very reactive metals, very active metals. They are obtained by the electrolysis of the chlorides. For example, sodium chloride, lithium chloride, magnesium chloride, aluminum chloride. Sometimes we can also use oxides like aluminum oxide to obtain this active metal. They can be synthesized by using electrolysis process in the electrolytic cell. So this is an application of electrolysis. We can also write electrolysis of ionic compounds, salts like sodium chloride. So when you make sodium chloride, you can get Na plus Cl minus. So how can we write? Anode reaction or oxidation of reaction can be written as Cl minus. Why Cl minus? Because anode is a positive electrode in an electrolytic cell. We are talking about electrolytic cell, okay? So Cl minus is an ion. It is a negatively charged ion. Therefore, it migrates toward anode, then discharged by what? Losing electron. So anode half reaction or oxidation half reaction can be written as Cl minus then half of Cl2. Why? Because chlorine is a diatomic molecule. It must be written as Cl2. But we need only one Cl atom, one chlorine atom. Therefore, to get one chlorine atom, so divide it by 2. And then to balance the charge, one electron must be added here. So plus one electron. Now the charges are balanced. We have -1 on the left hand side of the arrow, and also we have -1 on the right hand side of the arrow. So already the charges are balanced. So this is oxidation half reaction, or it is also named as anode half reaction. Okay, the second one is cathode reaction or cathode half reaction. It is also named as reduction half reaction. So sodium plus Na plus, this is cation, okay, positively charged ion. It migrates toward what? Cathode, and discharged by gaining electron. Okay, simply it can be written as Na plus plus 1 electron, then Na, sodium metal. So this is reduction half reaction. Why reduction? Because here we have +1, okay, but the oxidation number 4, this sodium metal, is equal to 0. Therefore oxidation number decreases. If oxidation number decreases, that reaction is simply known as reduction of reaction. But in this case, we have only -1 charge on the left hand side of the arrow. For this chlorine, its oxidation number is 0. Oxidation number increases from -1 to 0. Therefore, it is an oxidation process, and it can be named as oxidation half reaction. Same reaction can be written as cancel this 1 electron by this 1 electron, then add them together. Na plus plus Cl minus. Right here, electrolysis. Then Na plus half Cl2. So this is an electrolysis of molten or fused sodium chloride. Anode reaction. I already told you about this one. And it can be named as oxidation half reaction. And your cathode reaction or reduction half reaction is Na plus plus 1 electron, Na. Now the electrons are equal. We have 1 electron on the right hand side of the arrow, 1 electron on the left hand side of the arrow. This can be cancelled by this 1 electron. Therefore, the same reaction becomes Na plus plus Cl minus, and in the product side we have Na plus 1 over 2 Cl2. So this is your same reaction. Na plus plus Cl minus by electrolysis, Na plus half of Cl2. So this reaction is redox reaction. Okay, example number 2. Electrolysis of molten lead to bromide. Okay, so after melting this lead to bromide, we will get this cation and 2Br minus anion. Therefore, we can easily write the anode half reaction as well as cathode half reaction for this type of electrolysis. How can we write? For example, in the case of anode reaction, 2Br minus by losing 2 electrons. So Br2 can be formed in the product side. The anode reaction, 2Br minus Br2 plus 2 electron. 2 electrons are lost because here we have negative 2 charge on the left hand side of the arrow. But the oxidation number for this neutral, okay, neutral molecule is equal to 0. Therefore 0 minus 2 is negative 2. On the left hand side we have also negative 2 charge. Now the charge is balanced. So this is oxidation of reaction or anode reaction. Cathode reaction is Pb2 plus this cation, okay, migrates toward what? Cathode, and discharged by gaining electron. How many electron? 2 electron, because 2 plus negative 2 equal to 0. Now the charges are balanced. Therefore 2 electron must be added on the left hand side of this half reaction in the reduction of reaction. The same reaction or overall reaction is Pb2 plus 2Br minus 2 electron can be cancelled by 2 electron. So Pb2 plus 2Br minus, so Pb plus Br2 is oxidation reduction reaction, or it can also be named as cell reaction or overall reaction. So this is electrolysis of molten or fused lead to bromide. Okay, summary. Okay, let us see the similarity as well as the difference between galvanic cell and electrolytic cell. Galvanic cell can also be named as voltaic cell. So what's the difference between the two? What is the similarity of these two types of electrochemical cells? So in this case, for example, in galvanic cell, redox reactions that takes place in these cells are spontaneous. That means reaction occurs it is own in this type of cell, in voltaic cell. But in the case of electrolytic cell, the reactions are non-spontaneous. Here the reaction is spontaneous, here the reaction is non-spontaneous in electrolytic cell, in electrolysis cell. But in the case of galvanic cell, the redox reaction is spontaneous. Another main point, in these electrochemical cells, the anode is negative. I told you about this one. But cathode is positive in galvanic cell. But in electrolytic cell, anode is positive, cathode is negative. So this is the difference between the two. Another main point, the electrons originate from the species that undergoes oxidation reaction. Here, the electrons originate from the species that undergoes oxidation reaction. But in electrolytic cell, electrons originate from external source. What is that external source? Battery. Therefore, electrons originate from external source. Because of this reason, the reaction is non-spontaneous chemical reaction. Energy released by spontaneous redox reaction is converted to electrical energy. In galvanic cell or in voltaic cell, chemical energy is converted to electrical energy. But in electrolytic cell, electrical energy is used to bring about chemical changes. Therefore, electrical energy is used to drive non-spontaneous redox reaction. So this is your oxidation of reaction in galvanic cell or in voltaic cell. Y, 2Y plus plus 1 electron. Reduction of reaction, Z plus plus electron, then Z in this type of chemical reaction. Reduction of reaction for galvanic cell. The overall reaction, cancel this electron with this electron, then Z plus plus Y, Y plus Z plus, and in the product we have Z plus Y plus. Delta G for this chemical reaction is less than 0. If delta G is less than 0, the reaction is spontaneous chemical reaction. But in the case of electrolytic cell, your oxidation of reaction is X minus to X. Why? Because X minus is anion, it migrates toward anode and then discharged by losing electron. I already told you about this one. So this is your oxidation of reaction in electrolytic cell. Reduction of reaction in electrolytic cell is M plus plus electron, M, the overall reaction. So here we have 1 electron, here also we have 1 electron. This 1 electron can be cancelled by this 1 electron. At the end we will get M plus plus X minus M plus X, and the delta G for this chemical reaction is greater than 0. If Gibbs free energy delta G is greater than 0, that chemical reaction is non-spontaneous chemical reaction. So this is all about electrolysis. Let us practice just by answering these questions. And the question number 1 says, which one of the following solution shows no current flow in an electrolytic cell? Water solution of table salt. In this type of electrolyte, current will flow. In molten sodium chloride, we have ions. Therefore, current will flow. If it is in solid form, current will not flow. But after melting or after dissolving sodium chloride in water, current will flow. These are simply known as electrolytes. Hydrochloric acid solution, this also an electrolyte. Therefore, current will flow in hydrochloric acid solution. But sugar solution, this is not electrolyte. It is non-electrolyte. Therefore, the correct answer for question number 1 is D, sugar solution. In this solution, no current will flow in an electrolytic cell. Therefore, D is the correct answer. Okay, question number 2. Which of the following is not correct about voltaic cells? The anode is negative in voltaic cell. This is correct. The cathode is positive. This is also correct. But the question says which of the following is not correct about voltaic cell? Oxidation takes place at the cathode. This is false. In both electrolytic cell and the galvanic cell, oxidation takes place at the anode and the reduction takes place at the cathode in both types of electrochemical cells. D, redox reactions produce electricity in the cell. Therefore, this is also true. It is correct. So C is not correct. Therefore, the answer for question number 2 is C. Question number 3. Voltaic cells and electrolytic cells are similar in that A, the anode is positive and the cathode is negative in both types of cells. This is not correct. Anode is positive in electrolytic cell but negative in voltaic cell. And the cathode is negative in electrolytic cell but positive in galvanic cell. So A is not correct for this question. Okay, B, oxidation of reaction occurs at the cathode in both types of cell. Oxidation of reaction occurs at anode. I already told you this one many times. Therefore, all the time remember that oxidation of reaction occurs at the anode in both types of cell. But reduction half reaction occurs at the cathode in both types of cell. Therefore, this is also not correct. C, both types of cells contain 2 electrodes in contact with electrolytes. Both types of cells, okay, contain 2 electrodes, anode and the cathode, in contact with electrolytes. Therefore, this is true. But D, reduction half reaction occurs at the anode in both types of cell. This is not correct. Reduction half reaction occurs at the cathode in both types of cells, in electrolytic cells as well as in galvanic cell. So the correct answer for question number 3 is C. C is the correct answer. Question number 4. The branch of chemistry that deals with the study of a relationship between electrical energy and the chemical energy is simply known as electrochemistry. I told you the definition of electrochemistry. So the correct answer for question number 4 must be B. Okay, question number 5. Electrodes are made of what? A, metalloids, B, non-metals, C, alloys, D, metals. So the correct answer for this one is from metals, strip of metal. I already told you about this one. So the correct answer for question number 5 is D. D is the correct answer. Question number 6. Which of the following occurs during the electrolysis of molten binary salt of a metal? I already told you how to write the electrolysis of molten electrolytes. Molten sodium chloride, molten lead to chloride. So let us see molten binary salt of a metal, MX for example. For MX, after melting, we will get M plus plus X minus. What is the anode of reaction? Or anode reaction is X minus then X plus 1 electron. What is your cathode reaction? Your cathode half reaction or reduction half reaction is M plus plus 1 electron then M. So which one is the correct answer? The metal will deposit on the cathode. On the cathode we will get metal. So this is correct. Reduction will take place at the anode. This is false. Reduction occurs at the cathode in both types of electrochemical cells, in galvanic cell as well as in electrolytic cell. Oxidation will take place at the cathode. This is also false. Oxidation will take place at the anode, not at the cathode. So A is the correct answer for this question. No current will flow through the molten salt. This is also false. Current will flow through the molten salt, and the current flow is from the cathode to the anode. It is opposite with that of the flow of electrons. Therefore, the correct answer for this question is A. A is the correct answer. Okay, question number 7. During the electrolysis of fused lead bromide, the anode of reaction involves what? Lead to bromide. Already we have seen about this one. Pb, Br2. After melting, we will get Pb2 plus 2Br minus. So what is your anode half reaction or anode reaction? So in anode reaction we have 2Br minus, then Br2 plus 2 electron. What is your cathode reaction? Your cathode reaction or reduction half reaction will be Pb2 plus 2 electron, then Pb. Therefore, during the electrolysis of fused lead bromide, the anode half reaction involves anode half reaction, oxidation of this bromide ion to bromine molecule. Okay, so oxidation of lead atoms to ions. This is not correct. It is reduction of lead atoms, and this also occurs on the cathode half reaction. So A is not the correct answer. Reduction of bromine atoms to give bromide ion. This is also not correct. So all the time in anode reaction, it is oxidation of bromide ion to the bromine molecule. Oxidation of bromide ions to elemental bromine. So this is the correct answer. D is the answer for question number 7. So this is all about electrolysis. Thank you for watching. Thank you for listening. So see you next time. Until then, bye bye.